The information technology revolution has changed our lives, and the future of computing is tremendously exciting. But unless we find a new form of electronic technology that uses significantly less energy, the growth of computing will become limited by an energy crunch within decades. Computing already consumes about 8% of global electricity, an amount that's doubling every decade. If the future demand for computation growth cannot be met by global energy capacity, this conflict is expected to choke further growth. Machine learning and artificial intelligence have potential to transform fields from manufacturing to vaccine development. Self-drive cars could virtually eliminate traffic deaths. On-demand, instant translation services could further improve our global connections. But this future will not happen if computing fails to become more sustainable and energy efficient. Fleet seeks a new generation of energy-efficient electronics to enable the continued sustainable advancement of computing. The processing of information takes energy, whether it's streaming music and movies or modelling the weather. Every time we perform a computation, we must pay an energy cost. Anyone who has ever balanced a laptop on their legs will know how much heat can be produced by a functioning computer. This heat represents wasted energy. But the bulk of the energy in computation is consumed invisibly, in thousands of massive factory-sized data centres around the globe and in the networks that connect them. So how is Fleet addressing this challenge? Running a computer will always consume some energy, but we are several orders of magnitude away from computers that are as efficient as laws of physics allow. Recent advances in physics and material science provide solutions to this problem via new quantum materials that could replace the silicon-based technology that's been the backbone of computing for the last 5 decades. The first significant advance is the discovery of two-dimensional materials. It all started a little over a decade ago with graphene, which is comprised of a single layer of carbon atoms. But there is now a virtual zoo of atomically thin materials, including metals, semiconductors, insulators, and more exotic quantum materials such as topological insulators, superconductors, and ferromagnets. Fleet scientists are studying these novel two-dimensional materials to seek future electronics that can switch without wasted dissipation of energy. Another significant advantage is in topological materials. These are an even more recently discovered quantum class of materials, with Fleet putting Australia towards the forefront of research in this field. Topological insulators conduct electricity only along their edges and strictly in one direction. This one-way path conducts electricity without loss of energy caused by resistance. Fleet researchers were the first to successfully develop a topological material that could function at room temperature. Via application of an external electric field, this material can switch electrical conduction on and off, providing the binary ones and zeros of classical computation. The combination of researchers from diverse areas of science is a key component in Fleet's success. Fleet combines expertise from material scientists, electrical engineers, cold atom physicists, and condensed matter scientists, and the work of experimentalists is guided and supported by skilled theoreticians. Research success is dependent on integrating these diverse skills and perspectives to work in harmony. As well as Fleet's core research mission, the Centre addresses wider issues such as equity in science and improving science literacy in the community. Fleet places a high value on equity and diversity in the workplace. Women are underrepresented in science, particularly in physics, and in this regard, Fleet is no exception, but we are taking steps to improve this. While we still have more work to do, Fleet has increased female representation at every level, from senior advisors to early career researchers, with 27% of women, up from only 18% in 2017. The Centre has introduced a series of innovative fellowships and scholarships, allowing Fleet to increase the percentage of women at early career and associate investigator levels to above the average in the fields of physics and material science. The original Women in Fleet Fellowship sought the best female talent across wide areas of expertise and geography. This much broader search allowed Fleet to find excellent researchers who may have been missed in previous, more narrowly targeted searches. It's one example of Centres of Excellence' ability to champion new ways of working in the science community. In another example, Fleet has sought to lead changes in family-friendly conferences. We believe that conferences and workshops must work for researchers with families, rather than the other way around. From the outset, families and partners have been fully welcomed to all our meals and social events at Fleet's annual workshops and hosted conferences. And free on-site childcare is provided for all delegates, allowing parents to participate fully in lectures and seminars. Involving families and children at Fleet's workshops has transformed these events. In particular, the presence of children at scientific poster sessions and social events creates a really fun, uniquely enjoyable atmosphere for everyone, and not just the parents. Fleet only funds events that consider equity and diversity in their speaker selection, family-friendly policies, and overall event organisation. Research confirms that diverse teams do better research. Within Fleet, we know that by improving our performance with respect to gender equity and diversity, we are not only doing what's fair, we will improve the effectiveness of our research teams. There is still much to be done in this arena within Fleet, and the Centre is now expanding its focus to address other areas of diversity, such as culture, sexuality, and gender identity. Another important area of focus for Fleet is science outreach. The Centre set itself very ambitious goals for outreach and communication at the outset, including requiring 20 hours of science outreach from each member each year. Even with the unprecedented challenges to face-to-face outreach posed last year by lockdowns and public gathering restrictions, Fleet continued to conduct outreach. Innovative Centre members generated home science videos during lockdown, came up with an inexpensive DIY solution to create a virtual light board, and delivered skills workshops on graphics, animation, and perfecting the science pitch. Other researchers helped deliver virtual lab tours of Fleet facilities at Swinburne University of Technology, UNSW, and Monash. Even in 2020, Fleet reached over 2,200 members of the public, 1,600 students, and 260 teachers. Science outreach is an integral part of communication of Fleet research, and the Centre's high focus on outreach has resulted in improved science communication skills for Fleet researchers. Skills honed by members on explaining Fleet-relevant science to school students has proven invaluable in later explaining the value of their research to politicians, business contacts, and potential investors. Our ever-growing demand for computing capacity must be met with gains in computing efficiency. Otherwise, the information revolution will be throttled by the cost and availability of energy. Achieving this sustainably means finding novel, energy-efficient technologies. This means a new generation of electronics and a radical shift from the silicon-based CMOS technology that has been the backbone of computing for the last 5 decades. Fleet's research will help avoid the predicted energy crunch on future computing. In the process, Fleet is positioning Australia at the forefront of new semiconductor technologies, changing the culture in STEM research and training a new generation of Australian scientists.